Today's question takes us back to the specimen papers, specifically the Chemistry Paper 1 Foundation tier. And this is all about the energy changes unit and lurking in about the reactivity of metals from the chemical changes unit. Some students investigated the reactivity of 4 unknown metals, W, X, Y, and Z. The letters are not symbols of these elements. The student used metal salt solutions of copper nitrate, magnesium sulfate, and zinc chloride. So these are the chemicals that we've got to use. Now, just taking a tactical pause here, you can see I've got a lot of preamble in this question. This is sometimes typical because, remember, if it's not in the specification, they can't ask you about it. So if they want to get you to analyse something or see something that is not explicitly taught, they'll write a lot so you can apply your own knowledge. This is the method used. Pour a solution of a metal salt into a glass beaker, measure the temperature, add 1 gram of metal, measure the temperature, and calculate the temperature increase. So this is our displacement reaction, and it's an energy changes required practical. If you want, I can look at some more required practical stuff in the future. Students did it using each of the salt solutions. Figure 1 shows the apparatus used. I think pretty self-explanatory there. Student shows the results. If we think about displacement reactions, displacement says that we need a more reactive substance replacing a less reactive substance in a compound. While we think about this is, if I have something which is less reactive, it's not going to kick it out. We tend to think about displacement reactions as the other ion involved is kind of going to the most reactive, the most attractive, and like, whoa, check out that ion, what a beauty. So if I'm less reactive, it's not going to leave its boyfriend or girlfriend or whatever, however badly and style you want to think about it. So if I've got no change in a reaction, that suggests that what I've added was less reactive, so it doesn't want to react. So if I look here, metal Z is not replacing any of these. So that means that this must be less reactive than all of them. Because if it was more reactive than any of these, it would replace it and we'd see an energy change. So we know that metal Z must be the least reactive. Now, if I look at magnesium sulfate, the same thing is kind of going on here. There's no change. So that means that kind of the sulfate is most happy with the magnesium, i.e. it's the most attractive ion that sulfate could be with in this situation. So that means that magnesium must be more reactive than all of these metals because these metals are not able to replace it. How do the results show that magnesium is more reactive? It's simply the magnesium sulfate does not react with any of the metals. So moving on to the next part of the question. How do the results show that the reaction between metal Y and copper nitrate solution is exothermic? Well, if I look at metal Y and copper nitrate, we can see here I've got a 29-degree temperature increase. Exothermic, if I look at that word, thermic is all to do with energy or heat, and exo mean, you can think of that like exit. If I am exiting heat from a reaction, that means the temperature gets hotter. So simply, it is that the temperature increases. Part D. A student said that the investigation was not valid. Fair test. So when we think about fair tests, we are really thinking about control variables, keeping things the same. Write a plan for the investigation that includes improvements to the method and apparatus. This is why I've got this side-by-side set up, so we can really look here. And actually, that's the thing to note, is if there's something which you're really going to have to refer to, exam papers tend to make sure that it is printed side-by-side, so you don't have to flick back on the exam. So this is the method used. We've poured a solution of a metal salt into a glass beaker. So first of all, we need to be specific with the amount. Measure the temperature, nothing wrong there. Add 1 gram of metal. That is fair, we're adding a specific mass. Measure the temperature of the solution and calculate the temperature increase. Other sources of things which could be unfair is you'll notice that they're stirring it. That means that we've got a good clean mix of the chemicals, but we could also be specific with the amount. When we say we've got to be specific with the solution, the 3 things that we can be specific about are the volume, how much, the concentration, how strong or weak, and then I suppose, even though it's less relevant here, the idea of mass, because actually that metal is added there. Something else though that we could be specific with that metal, and actually when I've done this practical in class, magnesium, we give it as a little strip, copper we get as little turnings, or iron we get as little filings, and that's unfair. So we also want to make sure that we've got the same surface area, because if I add one with a really low surface area or really high surface area to volume ratio, it kind of can react much more quickly. So let's put that all together into our clear and concise plan. Step one, I like what we're doing here, but let's be specific. Okay, so pour, let's say 10 centimeters cubed of 1 molar and metal salt solution. We can also actually use a polystyrene cup, because this would reduce our energy loss throughout to the surroundings. Step two is that I would record the temperature. I am then going to add my specific mass of metal, and let's just for argument's sake say it's a powder. And we can again continue that idea of being specific by saying stir 5 times. We then got our thermometer in there. We're going to see what the highest it goes to. And finally, we can calculate it, calculate the temperature change. And actually one more thing we can do is we can repeat it for all the different combinations. We can also run each experiment multiple times and take a mean, and that also helps our results. So let's say we repeat each combination 3 times and take a mean. Again, that's probably overkill, because I've mentioned more than 4 improvements there. And it's a 4-mark question. And remember, when we do a longer written question like that, we go for our level first. So as long as you're getting 2 or 3 really good improvements and a good solid method, that will unlock those highest marks. A question all about a bit of experimental technique, thinking about displacement reactions, and also how to deal with a lot of preamble.